Hello. So in this lab, we will be getting familiar with the Graviton provided by AWS, which is used to provide best performance for cloud interface. It is a microprocessor which is run on ARM-based interface. So here we can see that ARM processor, which is Graviton, which offer many benefits like up to 25% better performance, 2 into higher floating speeds, 2 into faster cryptography. Means there are benefits of using AWS Graviton processor. So we will in this lab we will be seeing how to deploy a website which is previously uploaded on into 86 Intel based architecture T2 micro, and how to migrate that application onto the Graviton based EC2 instances. So in this lab, our lab objective will be, first we will first, we will deploy our application on into 86 based EC2 instance with the help of Terraform, which is a web programming interface to deploy the web application. And then we will first we have deployed on into 86 architecture which uses Intel. Then we make some changes as we have to change the configurations, like we have to change the AMD processor to ARM processor as Graviton run on that. So then we will deploy the same application on Graviton based EC2 instance, which is T4G micro. So our and before all this, we will be getting familiar with the web application in architecture review, means how the requests are made. So this is our lab objective. That first we will deploy our project on into 86 based EC2 instance, which uses Intel, and then we will migrate our web application on Graviton, which is our objective of the lab. That is Graviton web app migration. That is, we will migrate our web application on the Graviton based browser. So what changes we have to make, and it will be easy to deploy our project on this. And this is our environment, that how front end and API listen. This we will be seeing in the further steps, that what is happening in this lab. So if we come to the objective, first we will open the means our environment which is provided by the Cloud Academy, and open the Cloud Academy web based general purpose ID to run command and deploy our project on the project using the Terraform. So first we will be getting familiar with the architecture review, that how what web application is provided in this lab, and how requests are made in the backend. So this will give an overview how requests are made. So there is a web application of voting web application is given. Whenever I click on +1, the request the browser will generate AJAX request and send that request to the API. Means whenever I click on one, browser will generate AJAX request and send that to the API, which in turn means that that request will be stored in the MongoDB database. Means that information will be stored in the MongoDB database. So now these are our three web means these are the three components of the architecture, that is web frontend, API which is developed using Go, and our MongoDB database. Now for a brief overview, that what happened when I first time open this web application. So when I first time open this web application, browser will send request to the main application front end. So HTTP responses will be getting, and then each programming language will make a AJAX request to get the information from the database. Means what is the present number of user which has voted, etc, etc. So that request will be sent to the API, and API will fetch data from the MongoDB and send that to the browser. So this is whenever I first time open a our web application. Now what happen whenever I click on the +1 button, means I perform a voting. So whenever I click on +1 button and perform voting, an AJAX request of updating the value will be sent to the API, and the API will change the value in the database, which is MongoDB, and success message will be sent. But main thing here notice is that in the front end configuration, our front end is listening on port 80. Now fr- front end will receive, or front end target group will receive data from the application load balancer, which is listening on port 80. Means in the in the here also we can see that application load balancer is sending data to the front end, which is listening on the port 80. Now, but also here please notice that API request is also being sent through the application load balancer, not through the front end. Means whenever I update any value, means in this diagram here we can see that whenever I update value, this browser is sending API request to update the value. But in actual the request was first sent to the application load balancer, and then because application load balancer has ALP DNS variable which hold the information where to send the API request, because front end does not know where to send the API request. Front end target group does not know where to send the API request. So that's why it's sent to the application load balancer, which is listening on port 80, and then that request will be sent to the our API load balancer, which we can see here also, that API target group which received traffic from the application load balancer. So this is this is our means overview of the web application architecture. Now we will deploy our web application on into 86 architecture, which is Intel based, and then we will migrate that application to the Graviton based architecture. Now in this step we will be deploying our web application on into 86 architecture, which is Intel based. So for this, first we will means open new terminal, then we will clone our web application code, which is provided in a which is which is saved in a Git repository and Terraform, with the extension of Terraform. So we will clone our repository with this command, and then we will change our directory to the application where application is saved, that is AWS Gravitation Web mitigation folder we will see. And we can see the content using the tree command, which we already used in the web reconnaissance lab also, that it perform a interface which is easy to read, that in module there is application interface where application data is stored, storage means where MongoDB database is stored, and main interface where all the main variables will be stored. And we can also see environment variables which is present with the help of this. Now we have seen the web application code that is present and available in the Git repository, and clone that using git clone command. Now we will set up our Terraform working directory to upload this project. Means we have to upload this project on our website, not website, we have to upload this project on our this interface. So but using t3.micro. So we have uploaded our project, and first check the that the work first change our directory to the Terraform working directory using this command, and then we apply our changes, means all the data that is present in the Terraform that we have opened. And autopro means we are uploading our object. So this will take some time, and upload our project, and then we will confirm if our web application has been successfully deployed or not. And we will see HTTP OK, and then we will click on this link and go to that application, and our application opened as it is deployed. But here we have deployed only on to T2 micro, which is Intel based. And whenever I click on this application plus one, then it will update, and we can see that what resources it is using by appending CPU at the end of the web application interface for the example purpose. So here it is showing it is Linux based, and this Intel based microprocessor. Now this project is deployed on into 86 based architecture. Now our next objective is to, which is our main objective, which is to migrate this web application interface into the Graviton based architecture. Now our next objective is to migrate our web application from into 86 architecture to Graviton based architecture. So for that purpose we have to change AMD 64 to ARM 64 based version, because that is prerequisite for Ubuntu 20.4 operating system. So if we have to run 20.4 operating system, we have to install and run our ARM 64 based architecture. So for deploying this, first we have to delete the first undeploy our project, which is we hosted using the Terraform, which is used for the deployment of the web application. So first we have undeployed our project using this command, and our project get undeploy within 10 minutes. So next we will see the environment variables or Terraform variables which are present, and instance type configuration of the web application. Here we can see that instance type configuration is t2.micro t2.micro. Then we change this instance type configuration to t4 t4g.micro, which is used for the for our means uh, which is used for the gravitation based architecture, which is deployed on the t4.micro to run t4.micro, which is gravitation based architecture. So we have changed here to the t4.micro from t2.micro. Now it will be running on Ubuntu based. Now when we see our application interface, here we can see that it is using AMD 64. So it has to connect with this our main interface, which is using t4 t5.micro, and its prerequisite is it requires ARM 64 based interface. So here we have changed this AMD 64 to ARM 64 based. This change, it is written here also, this change is required because server architecture is being migrated to ARM 64. Therefore, Ubuntu 24 operating system, which is being installed, server need that. So, as we have used T4G.micro in the previous step, that is Graviton, which is running on Ubuntu 24.04 operating system that require ARM 64. That's why we have changed AMD 64 to ARM 64. And uh, similarly and we will change our binary from AMD 64 to ARM 64, which is present here. AMD 64 binary to ARM 64, which is also required as we have changed our server architecture to ARM 64. Then a binary of that will be required for the smooth functioning of the project. Then in the database also main TF file, we have changed its AMD 64 instance type configuration to ARM 64 configuration. And then we deployed our project using the same command terminal Terraform interface, and deploy our web application and check if it is deployed successfully, and go to that web application and voted a vote means +1, click on +1, and can see configuration means configuration of the CPU. And here it doesn't provide very much information for the safety purposes, but give any hint that vendor ID is ARM and operating system being used is Linux. And then for the optionals project, so for the optional subject, we can also see in the EC2 instance in the interface of AWS Amazon that our T2 micro is terminated. That is, this front end application is running on T2 micro, which is terminated. This MongoDB is also running on T2 micro. This is terminated. Now our Mongo is running on T4.micro. Our front end application is also running on T4.micro, which can we can see. And so this will be changed to our Graviton based processor provided by the AWS. So this is our lab objective, which we can also overview that. First, we get overview of the web application interface, then deploy our project on x86 based architecture, then migrate our web application to the gravitation based architecture. So that's all for this lab.